All right, Keith, let's read the definition. Go.
The definition of the derivative, all that.
All that.
Explains why the derivative represents slope. Fortunately, there are some quick and easy rule of thumb. Taking derivatives is much less complicated.
So all this that was mentioned, if you've seen 2.1a video, it's basically defining the definition of derivative. So the way you guys were told to do on Tuesday was plug in x plus h, take f of x, and eventually something eliminates, and h is canceled, right? There's actually a shortcut behind it, but you have to know both ways. Because on the AP test, it's going to say using the derivative rule, then you have to plug it in. But if not, you can use a shortcut that I'm going to teach you today, okay? So let's kind of analyze what's happening. Circle 10x to the power of 7. And then circle directly below 70x to the power of 6. And I want to look at one component. Look at your powers. The power of 7 to power of 6. It became how many less?
1.
Okay? So now circle the next component. I have power of 4, and did it really go down to one less? So that's the rule for the power. Now look at the coefficient. What happened to 10 and 7 to get a 70 as my new coefficient? Multiply. And the next one. What happened to the negative 5 and the 4 to get that new coefficient? So you have your rule. The simple derivative is multiply the coefficient and the power, take one less of the power, and that's it. Is somebody on their phone hiding with their spiral? No? Put your spiral down. All right. So I'm going to give you a general rule with an example, because for me, definitions do not mean anything, but the examples mean a lot more. Put that down. Let's all write out negative 2 x to the power of 4. If I ask you to find the derivative of this, what 2 do I multiply? Which 2? Negative 2. And 1 less is 3. And let's say I go, well, let's find the derivative of that current function. What 2 am I multiplying? Which is 24, negative 24 x to the power of 2. And we're going to keep going down for the teaching purpose all the way down to some number. Now we're going to further multiply. We get negative 48x. And yes, you can write it to the power of 1, but I'm not going to write that out. So the next piece. What do you think the derivative of negative 48x is going to be? Just negative 48. Because notice that x becomes 1 less, and x is gone. So my next one. If I give you a derivative of a constant without a variable, a whole number has a derivative, what do you think? 0. Because I can't go on any further. So write out something on the side. Derivative of a constant, that's a constant, is always 0. Now I'm going to talk about Unit 1 tests for some of you guys that do not know how to write zeros. So this one has nothing to do with this problem, all right? But I have noticed something, and I want that to be gone from here on out. So listen up. So on your test, some of your answers were approaching 0, the limit, right? I've seen students write out 0. That's great. I have also seen students write out 0 with a slash within the circle. That is okay. The reason I say it's okay is because of this. When you are rushing and you're writing things fast, here's what some kids will do just because they're rushing. This means no solution. So don't give me that. So I want this instead as a norm. So what I did on the test was, student that gave me one like this, I had to go to the second page and the first page and investigate their handwriting. I should not have to do that. Is everyone clear on that? Okay? So don't try to give me a fancy 0 and rush and give me a slash like this. Is everyone clear? Okay? So nothing to do with the problem, but let's move on. All right. Let's see. Chloe, let's read number 1 on the bottom there.
Find the derivative of g of t, or over 5t to the second, and the slope of the graph at t equals 2.
Find the derivative. Derivative is a slope function. So for this piece, I'm going to write everything out. After this page, I'm not writing everything out. All right? So My derivative is my prime of t. You take the coefficient, multiply that by the power. In my power, this one is understood 1. And 1 less is t to the power of 1. So when I simplify this, I'm going to get g prime of t is equal to 8 over 5 t. And this is my slope function. Derivative is slope function. So here I have it. My second portion says, using the slope function, plug in the 2. So we are going to plug in g prime of 2. So I have 8 over 5. T is represented by the 2. That is 16 over 5. And yes, if you want to make this into a mixed fraction, go for it. But I'm okay with that. All right. So let's kind of get fancy on the next one. If I lose you guys on the power rule, exponent rule, because you forgot algebra 2, come in for tutoring. So here I go. We want to rewrite this. 2 times t to the 1/2 minus 2 times t to the -1. That's our power rule. So if I lost you on this, come see me tomorrow morning. Y prime is equal to. So we have the coefficient of 2, the power of 1/2, and when I take 1 less than that is -1/2, minus a coefficient, the exponent, 1 less than that. Also, if you're having a hard time subtracting 1 and adding 1, come see me in tutoring. You're like, what? All right. When I compute the first set, isn't that 1? So I'm just going to write out t to the -1/2. On my second one, we have 2 negatives. So what do I have? Positive t to the -2. And having a negative power is considered improper. But the way you'll see it on a multiple choice, it's going to be 1 over the root t plus 2 over t squared. So here's the good news. If your AP test question were to have been a multiple choice, you go all the way. If you want to just plug it in and go, you know what, I don't want to simplify any further, that will give you full credit as well for free response. Let's cross off number 4 because number 6 has this problem already embedded. It's going to be redundant. So let's rewrite number 3. I see 1 over 5. I have an x in my denominator that I need to bring as my top, -2/3. That's our power rule. Our prime is going to be the following. The coefficient of 1/5, the power of -2/3, and 1 less than that is -5/3. We want to simplify this one more step further. It's going to give us -2 over 15. And because that power is it's a negative, I want to bring that as my third root, x to the power 5, and we're done. Okay, let's go to our last page for 2.28. So again, if you need a refresher on exponent rule, come see me. If you can't add 1 and subtract 1, come see me. You're like, what? All right, last page. We're going to add onto your flashcard on the back of our derivative flashcard, but not at the moment. I want to first show you what this basically means. I am going to show you why sine, or what the derivative of sine of x is. So going back to pre-calc, sine starts at the middle and ends at the middle, and it goes up and over. So if I ask you to graph the derivative function, I need to first plot out, where's my slope of 0? Line that up at y equals 0. And I'm not making all that tick mark since that was on the last lesson. So here I go. Is my graph going up? So it has to stay above 0. How about this one? Is my graph going down? It has to be below 0. Is my graph going up right here? It has to stay above. So I'm going to highlight this piece to emphasize what trig function this is representing. What was the one that looked like a bowl, top to top? Cosine. And I'm going to write cosine of x with the parentheses. You don't have to. So I'm only going to prove that one, all right? So then cosine, the derivative of cosine is negative sine of x. So if you're using a flashcard, because if not, use a corner of your paper on the back. Let's go ahead and add trig derivatives that we will eventually need to memorize. And notice I have some space on the bottom, but there's 4 more that I'm going to write on the bottom, maybe next time. And d over dx means derivative. You could say the prime instead, but let's get familiarized with all of them. All right. Let's resume to number 6, yes? Do you see number 6 has number 4 already embedded right there, like I said? Okay, let's start by rewriting this. So I'm going to rewrite this twice. First time, just converting from what I have, and second one by combining like terms. So I have half of sine of x minus 7 cosine of x plus the x. So here's the purpose of rewriting. We are going to distribute the negative to all the components here. So I have a negative 5. Now look at your x's. I have x cubed over x squared. Is that top heavy or bottom heavy? By how many more on top? 1 more. Now let's distribute the negative to the negative 7, positive 7. Is that top heavy or bottom heavy on the x's now? By how many more on the bottom? So I'm going to put that as a top with a negative 1. Distribute the negative x again, so minus 5. This one is completely bottom heavy. I know I need to bring that up with a negative 2. At this point, the only one we can combine like term is these two. So let's copy everybody as it is, but combine those two. Should get minus 4x. So we didn't do any derivative yet. But since our trig function is new for this section, let's circle them. So we have our prime. We are now deriving. Let's keep the half. What is a derivative of sine? Cosine. Minus 7. What is a derivative of cosine? Negative sine, so let's make that positive. What is a derivative of negative 4x? Negative 4. And then let's do derivative on the next one. The coefficient of 7 times the exponent is negative 7. 1 less than that is negative 2. Multiply the coefficient and the exponent, plus 10. 1 less is negative 3. So one last step is going to be writing this as a positive exponent. So I'm going to copy everybody except on that negative, bring that to the bottom. Done. And number 6 is something that we've done on unit 1. So let's see if y'all kind of remember. We got 2 more and we're done. Okay, let's find the limit as h approaches 0. It's something clever. Doesn't this sound like the derivative definition? Is that approaching a 0? Yeah?
Oh, yeah.
So let's assume we knew nothing about derivative rule. What was the first thing that I told you guys to do in unit 1? Plug in the 0. So 3 times. 8 plus 0 is 8 all squared is 64. Yes, I'm skipping steps. If you want to spend more time on it, go for it. H is 0. So what was the phrase when we had 0 over 0? Do more. Now something is wrong. Could I factor the numerator right now? So it looks like we're going to have to take the tedious step by multiplying this out. So write this twice to the side. If you want to double distribute, go for it. But I know a lot of us can do that in our head. So 3 times. What is that going to give us? 64 plus 16h plus h squared. And then we have minus the 3 times 64 I can't really do much about, and h. We know in the end what's going to cancel. Oh, if you remember, I said the last piece will cancel, and h eventually will cancel. So let's see if that is true. If I take 3 times 64, isn't that a 0 pair to negative 3 times 64? Yes. Let's go and cross that off. So I have remaining the following. Taking 3 and multiplying to 16 is 48h. Also multiplying to h squared is 3h squared all over h. Let's factor out the h on the top. So I get 48 plus 3h all over the h. Can I eliminate now? Can I also plug in the 0 into this right here? So when I take 48 plus 3 times 0, how many is that? Voila. That looks like 8th period. That's all I see now. That's a problem. Yes, ma'am. Yep. All right. Let's match the original function to the derivative with the neighbor for about like a minute. If you have to look at 2.1b, go for it. Match. Something cool is on the wall. On some of these, think about how many terms are there. There should be one less term on the derivative as a possible way to eliminate.
Oh, okay, that's the one, that's this one. So when that makes sense because.
Can I go to the restroom?
Please.
Take the pass.
Closest to the room.
That makes sense. I don't really understand.
All right, Max. The graph A matches with which derivative graph?
Should it be 1?
Because it behaves similarly? No. How many terms do I have here?
2.
Which is the only one with one term?
2.
Voila. So we know that one's gone. What about Marcy? B matches to what?
4.
4 it is. And if you're going how? Positive slope, it's above the 0. Negative slope, below the 0. Positive slope, slope above. Yes?
So for graphs like B where it has like the points on it with the no, whatever that means, does that
Mhm.
always go with
The open circle,
Okay.
yes. So where we have a cusp,
Gotcha.
not differentiable.
Okay.
All right, so then, let's see. Nick, what do we have for C? C matches to who? All right, and I'm gonna use process of elimination and go, you know what? It must be 3.